Hello, welcome to the next episode of AUTOMAT Live-Coding. Today we are doing something new, something that should address some of the issues that we are getting in AUTOMAT recently. So, one of the issues is that our FPS tanked. It used to be decent, it used to be hundreds of FPS, but for the past month or two, it's just trash.
Knight says,
Hey, everyone.
Hey mate. So here I have a Windows build and as you can see it's running at a fairly stable 60 FPS. When I move the screen with my mouse, okay, it tanked for a moment. But we are mostly interested in minimum FPS. This is the slowest frame over the last second. Yeah, when I pan the screen, it's fairly smooth. When I move it outside so that I don't see the timer, I guess it can get even better. But okay, so what happens? So this is what happens when I use my mouse. Now, when I use my fingers to drag on the trackpad, the FPS drops to something like 10. This is really bad. Even though I'm not zooming here, I'm just dragging fingers on the trackpad.
the
I think...
says,
Hi there. How it's going?
Hey man. Long time no see. Good to see you here. Oh, if you haven't been checking out, you should check the new website. It's... we've spent like 2 weeks working on this. So, I'm looking at this FPS issues here, and they all started when we changed the structure of our rendering loop to cache objects into textures. So caching broke the FPS. I don't have any kind of monitoring for performance regressions, but I guess this is the issue. So this is one issue. Another issue is that, I don't know if you remember, when I was actually playing Black Myth Wukong, we kept having these issues that AUTOMAT was able to play it over and over, but after a couple of hours, something happened. The character was running like too long, it bumped into an enemy, and it desynchronized. So the event delivery is not super stable.
I have checked it. Latest Automate build 2. Lot of work last few weeks. No capacity to watch something in foreground.
If you... Let me find something else. Was it yesterday? No, it was like 2 days ago. I was doing like a very short presentation about AUTOMAT. I was talking about more even things that I don't usually mention on stream. Let me find this. It's recorded, it's on YouTube, but it's probably private. Yeah. There.
Mouthful says, URL.
Yeah, so today we're actually, it's nice that you came, because today we are planning a bigger project. So we have AUTOMAT. It has like a decent website, still plenty of things to update. You know, documentation, we should record a new video, lots of stuff. I just wanted to like fix the directory structure. Separate www and docs. But we will do this another time. Maybe I will do this off stream, because this is not very interesting. So this is what I want to focus on today. Fixing the jittery event delivery. And we actually have this on the timeline roadmap. Here we have jitter regression test and multi-threading. Multi-threading is the solution that I kind of see here, because big part of the jitter that we have. Oh yeah, I can do this on YouTube. So the issues that we have with jittering, it comes from the fact that we are rendering on the same thread. So rendering, which is rather slowish, is taking the time of the logic thread and it's pushing it in time. So even if we get like a wake up from the operating system because the timer fired, so timer fires.
Evil Root says,
Could you please duplicate on YT? Twitch login will take some time.
says, Hello Marek Mafrogalski. This is a reminder that TTS only works in English. Please use English in chat. Thank you. The Evil Root says,
Thanks.
TS only works in English.
Oh no, I messed up my, okay. So I have a new feature on stream. This is something that detects Polish language and deletes those messages automatically. Okay. Cool. So I have this feature that automatically detects Polish and just deletes those messages and just gives an announcement about the language. Anyway. So we are going to fix this. We have a jitter regression test already in the works. So we started working on this. I hope that maybe we'll finish this today actually. I want to record some sample traces about how stable is our event delivery currently. I want to test it under load, so we will have some timers ticking, some dynamic animations in the UI to really ensure that rendering is super slow, that it's dragging the core. And then I want to see how multi-threading and how different fixes will affect it. So we'll have a benchmark. So this is going to be our bench or test. And I've already started kind of drawing the new kind of architecture. So we will be, this is important, we will be super multi-threaded. Each object, I mean, I wrote a prototype of this a couple of weeks ago. It was working fine. I think we can switch to something like that. So each object essentially is going to have a mutex in it. Mutex or something else, depending on the object. Some objects don't need any kind of locking. And because of that, objects will also be stored not in unique pointers, but in shared pointers. And the same applies to widgets. So we'll have much more so we'll have shared pointers and weak pointers. Weak pointers are going to be super nice for like representing trees. I think a lot of stuff will be simplified because of that. I also think that we should have, okay, we will have different widgets on the location in the widget tree where the object is displayed. Okay, I'm not going to write it here. Okay, so we will have objects and widgets, which will be kind of thread safe. And this multi-threadedness, we are actually going to not use this actually at all. Most of the execution, like when an object is being called, it's going to execute on the single thread that it was called in, and it will immediately return the next object that should be executed next. So this is going to be the, let's say, execution model that we are going to use. If an object wants to execute some extra tasks, in addition to like multiple successors, it will push them on the task queue. We will have a global task queue. This is going to be like the only main global object. But the main thread of execution is going to actually not use the task queue at all. Objects are just going to return the successors using the just return value. And the caller, which calls an object, they will be able to decide whether they want to continue this execution. They can like call some loop to execute the whole chain of objects. So we'll have some probably helper functions for executing sequences of tasks. And this means that objects are actually not going to care about threads at all. The objects are not going to use threads. Objects are going to be just single-threaded. Any extra work is just going to be put to this extra task queue. Alright, so maybe we could even have the caller supply a custom task queue. We will think about this. The same applies to widgets. Widgets are also going to be callable from multiple threads, and the widgets are going to form a tree. So here we have a tree of widgets. Like each object can have like an object like this one, can have multiple widgets underneath. And the widgets, because they have to be rendered and the rendering takes time, and the rendering can be cached in textures, we'll actually use that to have separate render threads. Or maybe, yeah. So by default we'll have render threads that will take care of this aggregation of objects into textures. Because when we do that, for each object, and it's like top level widget, we will have a top level texture. Like all of those objects will have their own textures, but we will have this like very, very top level window object, which is going to be just a single texture. So from the top level perspective, our operating system thread, we will be able to display stuff just ridiculously fast. Yeah, our OS thread is just going to just get the most recent texture, we will have something like maybe not double buffering, but we'll just use the canned texture and dump this to, to the display. We also have those worker threads. Worker threads are going to be an optional element. They are going to be, like worker threads. They look at the task queue and they pick a task and they start executing it. When they pick a task, they don't just execute a single task, because the task, like here, a task can have successors. So a single worker thread is actually not going to use the task queue a lot. It's just going to get one task and execute it probably for a long time, because a single task can have many successors. If a task forms a loop, that loop is going to be executed on the worker thread just forever. The worker thread is never going to look at task queue, it's never going to communicate with anybody else, it's just going to focus on executing the object in a loop. The object is still going to have mutexes, so it's going to take care of this locking so that the render thread will be able to render it from the side. So we have a new kind of top-level architecture of arranging the execution. So that's the plan. And hopefully this should help just fix the FPS. The FPS should be 60, always 60. Okay. So things that I want to do on the stream today. Maybe I can highlight them here. I would like to clean up some things, but yeah, maybe let's work on this jitter regression test.
I like QWorkers architecture, but never actually implemented it for render. That would be interesting to watch.
It feels really like the GNU Make. The tree of textures. In the same sense that you have dependencies in Make, and those dependencies, files, they are sometimes updated. Access time is like, the modification time is changed. And then you know that you have re-render a couple of textures and aggregate them into something top level. I expect some friction with the... I think it may be hard to mesh it with input, because all of these so we are going to have this clash of events that are happening at a different cadence. So we have display refresh. So this comes from the Vulkan. So this is usually locked to 60 FPS, but can be, like on Linux, on the Xorg it's not locked. So this is one. We also have the... Okay, actually on Vulkan it's not locked to 60. I think on Windows we are getting paint events from the main loop. I think we are getting this WM paint event. I don't remember, I will have to read in the code to see how that works. We have input, which is between 100 and I think, you know, high performance mouse are even 8 kilohertz. I guess 1000 is more common probably. I think standard mice are 125 Hz. So touch screens and digitizer. We also have some objects that want to be rendered continuously. So for those objects we can think of like the update rate as infinite. So we have all that, and we can have we could have multiple displays. So we often assume that we want to render to RGBA. It's not always the case. Sometimes, especially when you want to render text at low resolution displays, this actually requires knowing the pixel layout. Even, yeah. So meshing these together, this is tough. So display refresh, which we want to have as fresh as possible result always. And caching. Okay, we will figure out the solution as well. For example, how do we store the So we obviously want to store this as a texture, but Sometimes we render only part of an object. This can be rendered at a different zoom levels. So different transforms, different clips. Yeah, we will get there. Okay, jitter test. I think I can switch off the Windows PC. So we have tests, we have event bench. I want to run it. I guess it should work, right? Okay, I just have to run this file. Yeah, we dropped the exe. Will this work? I guess it should work. Windows should add the exe extension by default. I don't know what happened, it was fast. So first it built AUTOMAT, right? Then it started. Then the AUTOMAT window was restored at this position. Let me run this again. Okay, this is the actual test. Segmentation of, okay. It was a segmentation fault. Interesting. Okay, so let's debug this. Maybe I don't need debug automat. I need for, because VS Code only wants to use the debug version. But I think the regular version of automat should also, the one without debug, should also have some debug information. Okay, this is going to take a while. I actually wonder, where do we... Okay, it looks like WM Paint is not actually doing anything. Yeah, on Windows I think we have a separate render thread. Yeah, so the synchronization comes from Vulkan. So if I'm trying to think about the compositing loop. So this is how it looks. The compositor wakes up and tells us, hey, give me a new frame. So what we can do is, we do not want to render anything now. We want to just use the cached results. I actually wonder, maybe we could do some synchronous rendering. So when we render stuff, each object returns the animation. What was it called? Animation phase. It basically tells us whether the animation is finished or not, whether it can be cached or not. And I think that objects which return true, which means that they are animating, drawing them to textures seems like just this is probably what's causing the performance issues. We are just using too much textures and changing them too often. This is a problem because we are doing this back and forth. When we render to texture, we're asking GPU to render stuff, and then when we composite it, I feel like we are reading this from GPU memory. I think this is why it's so slow. Should never read GPU memory. Okay, so oh, it's almost finished. Yeah, so we will, in this double render approach, whenever a new frame comes, we will just render garbage first, but garbage that is roughly correct. So when we composite the cached textures, this actually there is just one top level texture. Okay, let's do this debugging. So I want to copy this state file, and now I want to run a debugger. Nice. We have a crash. I mean, there is a segmentation fault, but it looks like debugger didn't stop. Let's stop this. Copy the state again and run the debugger again. Maybe this is a just VS Code glitch. Okay. Pointer, what's the value of pointer? Yeah, it's null. Okay, I guess that's the issue fixed. Let's run the test again. I see the issue. Okay, enough. So when I run this test, I have to keep the focus within AUTOMAT because it sends these space events to itself. Yeah, you cannot see it, I have to move the window. After 10 seconds it stops. Okay, so it executed properly now. I just want to move this window. Output device X, yeah. Can I move it like 30 centimeters to the right? Almost. So in the state file, I have the position of the window. I guess the test was running on my Windows machine, so the window was slightly different coordinates. It's nice that the machine built on Windows works on Linux. And it stops. So the thing that happened now is that I can close this stuff. Now we have this. Those are timestamps when we pressed space. So it should be pressed at time, 0? Like every 100 milliseconds we should press and release the space. This is not exactly 100 milliseconds. So let's do some analysis, I guess. So this is our state. Now we have to navigate it. So we need to take root. And then we have a list of locations. So we should loop through the locations until we find a timeline with a space track. So this is our original timeline. And the second one is the recorded one. Oh, its name. Oh, get rid of that. Why do we work in debug console? how do I know which timeline to skip? It would be nice if we had something like UUID attached to each object to make it possible to select them from this list. And it wouldn't be an array, it would be a set. This is actually a good idea. Let's add this to the roadmap. So those are the time differences between what we should have and what we... we should subtract 100 milliseconds from each. So typically the delta should be 0.1. Oh yeah, this last one. Actually, no, it's fine. The worst case was 22 milliseconds of difference. Nice. I think the first array should be x values, so let's put plot it like that. Of course. I guess it's not a standard library. And just get it. This could be slow, but let's see. So I would like to have two things out of this script. One is the North Star metric, which is mean squared error versus expected time, and some helpers for debugging those issues. I think a good helper would be a graphical representation. So maybe not some basic diagnostics. Actually, mean squared error is probably not the best one. I think what we are really after is the This is something that's hard to measure because the operating system can mess up the measurement. Performance measurements needs to be isolated very well. The environment needs to be reproducible. So it's not easy to run this script. I mean, the results on different PCs are not really comparable. So we've been working on this. So this is the double render approach. So there is another approach where we could use, like, just take the cached texture and that's it. But we would assume We could go for a mix of rendering approaches. So in this approach, we would actually just check the cache and always use the cache if it's available. Otherwise, we would draw the object directly. Without any external textures. This could be nice because in AUTOMAT many objects, they are actually, when they are animating every frame. So doing this back and forth with textures is not really helping us here. Thinking of an extreme case, let's imagine a web browser. So web browser connected to like a decent machine, high resolution, high refresh rate, nice touch input, pen input, like a nice kind of browser terminal. I think this is something that we should optimize for. Which of those approaches would work there? So the web browser itself, it could be responsible for caching textures locally. Of course, right? Transferring them over the network is pointless. Okay, so the scenario would be imagine a web browser running on a like decent machine and Android AUTOMAT running on so AUTOMAT running on like a relatively low-end device. Raspberry Pi is not so low-end, but Raspberry Pi doesn't have the resources to render stuff at, at those in this context. So eager rendering would be very hard to pull off, because we would have to... So in this scenario, AUTOMAT is pushing drawing commands to the browser. So the browser is roughly aware of the widget hierarchy, but it knows nothing about AUTOMAT itself. In this scenario, the browser is a thin client. It can render the drawing commands, but the logic runs on Raspberry Pi. Yeah, this eager rendering. I don't know how it would look, because there is no way to provide back pressure between the browser and the Raspberry Pi. So if the browser is busy rendering something, it cannot signal to Raspberry, hey, I have plenty of work, don't push any more rendering on me. This double render would work. So we would composite the texture, we would send the request to AUTOMAT to re-render everything, and then we would get pushback, like a response with the new drawing commands for the new objects.
MacBooks Pro with 8 GB of RAM are nice browser terminals.
Yeah, exactly. It's really the hardware and the construction that matters there. Okay, this is funny because I actually had a version of AUTOMAT which did exactly that. Maybe I can find it. Give me a moment. It was like a very old project.
Oh, YouTube lost live when screen got locked unlocked.
Let me see. I mean on your side. Found it. I just have to extract this.
Yeah, when you lock screen or minimize YouTube, when open back, it does not restore to live time point, but continues from where you stopped.
This is not the one. I found the right one. Okay, when I was really using Go last time, it was like before the times of go.mod. Can I put this on my Go path? I had to specify a path, but okay, it's running. Now I should be able to contact this somehow. There we go. So this is an old prototype for AUTOMAT. This one is written in Go, and this one runs in browser, and it's using this rendering approach that I mentioned. I should be able to do stuff here. Maybe it's only using touch. What's wrong? Come on. Blah blah blah. Oh yeah, I remember. So I had this idea that the way to actually operate with this would be not using, mouse buttons, but keyboard keys. Because when I press my mouse, whenever you press the mouse usually moves a couple of pixels. So I thought that mouse could be kind of good for pointing, and when you point at something, you would press the key on the keyboard to do something. And this also gives you access to way more actions. You don't have just 2 or 3 buttons on the mouse, you have 100. Can I move stuff somehow? Let me just press every button I can. I don't remember how this worked. This is for moving the screen. I guess we would have to read the source code. But this is amazing that I just found a project from, when was it? It's more than 7 years old. And it just works. Something that just doesn't happen in JavaScript. Okay, let's get back to our plotting. Nice. So this line shows times and when we should have displayed when we should have sent the event. I expected something worse, honestly. We're not doing bad. But there are differences. So this is one frame off. Oh, and we should sort it using absolute deviation. Yeah, now it's even bigger. Probably zoom like that. And this is interesting because we see that here we've been too slow. Actually, we've been too slow always. And the slowness increases. There is a trend, a bias.
The evil root zero says,
Hello.
Hey there. Ah, you're checking the latency, I guess. Oh wow. This is a nice UI.
Oh, that's nice. I've got a Python script to send messages to chat from computer via terminal instead of typing on phone.
Nice. Twitch has a decent API. I mean, so many of them.
Eric all the way next door down. Do you still work on Gen 2?
Yep. Oh, actually the error is going to be way, way higher. Oh wow. Because we shouldn't subtract this delta from the last one. I'm afraid how large it's going to be now. 100 milliseconds. Okay.
How's it on long term for you?
So the only two things which are causing issues are when I want to install software, I often just, instead of installing it through image and portage, I often just go for app image because the installation is so slow and sometimes you get those stability issues. So I started running more and more software through app images now. But the system generally, so I used Gen 2 many years ago. I feel it's even more stable now than it used to be. In terms of running Ubuntu software, setting up the chroot with Ubuntu is a nice idea. Ubuntu is important because you want to have those libraries like that everybody links against, not the Gen 2, but so if you just pass like LD preload, something like that. For instance, I can run this DaVinci Resolve using libraries from Ubuntu. So compatibility is rather good. It's not actually good for bleeding edge. If you want bleeding edge, I would go for Arch. And the installation times are also nicer on Arch. I was trying to run Hyperland. And I've done this on stream a couple of times, but here I am getting just too many
Not
issues.
expected though. Compiling stuff from source is cool and stuff, but in daily workflow, it not always is fun.
Yeah. Gentoo is fun because sometimes the way to resolve an error is to actually switch to a beta version of software. More often than anywhere else, actually. I keep having those issues with the default packages that I just keep having to unmask experimental packages to use them because they are the only working ones. Okay, so this is the max absolute error.
I just bought more SSD space and thinking about ditching Ubuntu and try installing Arch for Workstation. Want to try these fancy WAMs for Wayland too? Ubuntu become as annoying as Windows for me.
Yeah, absolutely. You work on network, so I guess you're familiar with stuff like Ansible, right? Setting your system with Ansible is nice. I have a script that sets up my kind of required programs with Ansible, and this is the stuff that I can run on different operating systems. And Ansible is clever enough that it can install packages on different operating systems. So when I say, hey, I want Emacs, on Windows, it's going to install Emacs. On Ubuntu, it's going to install Emacs, using different means, using apt. And on Gentoo, it's using to install Emacs using emerge. So I have those Ansible scripts for setting up my personal environment. And I can test new operating systems this way. It takes time to write it though, but it's like... So Arch and Gentoo, they are like snowflake systems because you have to configure them extensively, and this configuration takes so much time. I feel like Ansible just solves this problem. You configure this once, and it, depending on the target operating system, it configures it using these OS-specific means.
I actually never used Ansible for production, only in lab. But I like the idea. Looking forward to research it more and apply somewhere.
Hey, this is nice. Let's get rid of legend. Yeah, we are generally always late. So I want to calculate drift. And maybe it would be good to repeat this test a couple of times.
I use CloudNet for basic configuration though. It's convenient with VMs and Debian Cloud images.
Yeah, I know that Ansible isn't the only one. It was just one of those frameworks. It's kind of like web. It's just so many of them. I actually wonder, where does the latency come from? So we are pressing space 5 times and then looping back. That could be causing issues. Because once timeline is active, the timeline should actually execute stuff according to the timeline. So I wonder if I put a animated timer here, that should tank the FPS, right? Could even do like 2 of them. I guess now stop recording. Now even delivery should be even worse. Yeah, because now we have like crazy FPS. Do we want to push it even more? Maybe we do. We don't need those deltas. We don't need this loop. And what it returns? Coefficients. I don't need that. So this is how many seconds is passing in the automat world during 1 real second.
It's not a performance issues, it's gravity then.
I wonder if we could see the step increase. So this here, this is like the first sequence. 1, 2, 3, 4, 5. And they have a relatively slow drift, small drift. 1, 2, 3, 4, 5, they have slightly higher. I think it could be increasing stepwise. So the scheduling is causing this drift. So this is caused by our scheduling issues, but there is also the inconsistency between events from the single sequence. One. I want to calculate this delta here because here we can calculate the jitter. In this plot, change this to false for now. So this is the first key press, second, third, fourth, fifth. and then we have a jump. I want to calculate the differences between those events within the single series. Maybe I will just call this jitter. Initially, jitter was very high, and then it went down, but the jitter is very stable. So this is why we were failing in Mario. Because we were just skipping frames, and this was just getting worse and worse as time went on. And the strategy that we employed there, which was to try to synchronize the state of the game with the recorded macro, this used to work. Okay, now let's push AUTOMAT a little bit more and let's make the test harder. So let's add some clocks ticking and rendering stuff. So this is a fresh execution of the test. We are pressing the space. This object is going to stop AUTOMAT in a moment. Cool. And now we can calculate a new result. We could actually store those values somewhere. This may have been worse because I was like moving my mouse over the window. It would be good to record this. Where can we do that? So let's create a CSV file. Checked in CSV file. Where we will have a date and results of those measurements. And actually JSON may be better. So some of the songs which are playing, they have those whispers at the end. This comes from my prompt to Suno. So if you listen very carefully, they say stuff like low pass effect and change of style. So don't worry, this is not... There are no demons in those songs. slightly different structure. We can see if this works. We have a nice graph. Drift, max jitter, this error, those numbers are very consistent. Let's try recording the result. Now we have a log of those values. Maybe we don't need to store them with full resolution. Let's do indent and actually we want more than 2. Tenth of a millisecond. It should be enough. So this max error is kind of redundant, I think. I don't think we need to store it. Okay, so we have the date of the test, which is today. Jitter was that, drift was that. We can repeat the test a couple of times to get reliable numbers, and I guess this is something that we can work with. So over the next streams, as we improve performance of specific parts, I hope we would see a drop in those values. So let's run the test maybe 10 times. Let's add a new option here. We have three values. Actually, I forgot about something rather important. I wanted to make the test harder by adding some extra objects like a timer connected to itself, a running timer. Like here. Let's see. With the issue with save, we left the space pressed down. Let's add one more. Now we have a much higher jitter. And drift is 24 milliseconds per second. Wow. This is what I wanted to see. Two more. Okay, they are all in the same ballpark. Like 20 milliseconds per second drift and max jitter around pretty high, 40 milliseconds. Wow. I would say that jitter regression test is done. Now let's start working on multi-threading. I mean, we already started thinking about this, but let's commit this and we can sync this. I want to see how this program works. Let's see. HTTP, okay. So we are loading an image, which is just a set of objects in a binary format. We are serving some static data. And on events, we have a WebSocket. Actually, two of them. So events are used to send input events. So this is for us synchronous and asynchronous. I think the magic may be happening in the static. Render ready. Let's It's when rendering starts. Okay, so during every frame we are sending a request to the server, and the server responds with the drawing commands. And the flow here is just amazingly simple. Request animation frame. If the socket is working, we just send the render ready. And when we are done, we are converting the response to string and sending this back to client. I think this is what we are doing. Yeah, so this tiny script allows us to render in HTML from Go. Oh, I actually had an image showing what key does what. Let's see. Okay, interesting. The tab key doesn't seem to work. Neither does Q. Exit also doesn't seem to work. I think this version is somehow broken. I don't know how specifically. Because those things should work. Well, doesn't matter. It's just an archival project. So we could use the same flow in this scenario. So request animation frame. And then draw request. And then we follow the drawing commands. This flow works because the cheap Raspberry Pi is actually perfectly fine managing the cache of the browser. We can have like a local copy of the cache so that we know what texture is cached, and we can precisely tell the browser, hey, now please create a new canvas with this size, follow those drawing commands. When it comes to eager rendering, I mean, probably we could do this in a browser. Off-screen canvas here. I mean, we could use this approach. There's actually nothing stopping us actually from eager rendering, because if we have a background worker, like web worker, rendering to an off-screen canvas, for those cached textures, we could send like confirmations back to the browsers. I mean, to the automat after rendering is finished. So that this could work, actually. I think there is something in Skia where we can record to a picture. And picture is just a list of drawing commands that can be replayed. So if we follow this, then for a mixed approach, we don't have to wait for the next frame. think this double render is going to be super glitchy. And we could have a mix. I wanted to draw one more thing, a tree of widgets. Let's use hexagons. Orange hexagons. This is our root window. This could be the toolbar. So this is an actual tree of widgets. This will be the machine. Or maybe it should be called canvas. Delete those things. Some object, let's say this is a hotkey. And that hotkey has a bunch of buttons. And there will be other objects here. We are just not looking at them. So So let's assume the first frame, nothing is cached. We want to render the contents of the root window. And those are actually widgets here. This is the location widget, toolbar widget, machine widget. And window is a widget, so quite often those objects are their own widgets. So we will, following this flow, call draw on root window, and this will, we have no texture here. Instead we are getting SK picture, which contains the contents of the window. But this actually calls recursively render for all of those sub-objects. Eventually we hit the end of recursion, like the leaf node, which records fully its SK picture, returns it up, and now this object gets an information that this button recorded itself to SK picture and it returned animation phase finished. So this hotkey can actually put the button on the cache. Or the button itself could put itself. Yeah, we have this draw cached, where each object can check whether it's in the cache. So Skia has this concept of layers. I think those layers, this is what we actually want, but the API for those layers is very minimal. This, we want that so much. So this allocates SK surface, but does not return it. This is interesting on a new surface. Maybe we could somehow use that. Canvas stuck. Make canvas from canvas layer. Maybe. Utils is always the best directory in any project. Clip stack utils, oh yeah. Yeah, Skia has a decent JSON parser built in. This is something that our syncos could do. I was just checking out new stuff. Let's look for more surfaces here. Very interesting file. Okay, let's go back to our plan. How do we weave in multi-threading here? Because in this mixed approach, we actually need to compute a huge SK picture, and we have to render it synchronously. And then we just copy some pictures into the cache. There is no background work here. In this eager rendering, it's really hard. Oh, and the strategy that I'm kind of following here is that we will just switch the rendering to a multi-threaded right away without any mutexes. And see how that works. If we will have to add proper thread safety to objects, but right now we will just let's make rendering multi-threaded. Okay, so here is one opportunity for multi-threading. When we have a widget, it usually has multiple children. Let's draw child cached. Draw cached. Okay, I think it will be easier if we explicitly say that how do we treat delayed values. So each frame is rendered at some time t. We can either render the uncached objects and wait for the rendering to finish. Or we could take whatever we have. But when we do this, we are rendering the old stuff. The user sees. I mean, it will be delayed either way, but So SK Picture has a nice advantage. The advantage of SK Picture is that actually it includes only the drawing commands. But if an image is being drawn, then it will also have reference to other textures. Okay, I think we will not start today, but we will do some thinking. I think we can figure out like a proper way to do this. Aggregation. I think it's worth to actually go through this exercise and figure out the algorithm before we start implementation, because then it will be just a lot of rewriting. The more I think about this, the more this eager rendering seems to be it seems like a very robust way, because this background renderer, it doesn't have to consume 100% of the CPU, it doesn't have to render in a loop. It can be a little more clever. So this approach, it has this advantage of being instant, absolutely instant. But there could be a lot of wasted work here, because objects which are never going to be seen by the user will still re-render. I think this is the expensive part. So this is the first opportunity for parallelism. When we iterate over children, we can actually add them to a queue. Option 1. And the option 2 is when we are drawing this, when we need to refresh a surface. can actually proceed with the old one. Okay, let's use the trick with escape picture first. Look at that, we can also serialize them. Huh. What we really need is the escape picture recorder. Yeah, let's recreate the identical matrix. Can't I just convert this? Okay, I can construct it. Okay, and this is where we render these to surface. And maybe get rid of the alt state. I guess we also have to end the recording. So recorder dot I wonder what's this bounding box hierarchy. They decided it's worth including in the API, so could be important. Oh, this is a spatial index. Nice. Yeah, this is super cool. I was thinking that I will need something like that. So we could do the culling, but I don't think we have to, because we want to draw everything from there. What's the difference between picture and drawable? Drawable is just abstract, right? Oh, this is interesting. Let's go for picture. This is safer. Seems we kind of need the old surface. There is, by the way, zero multi-threading here. We are just changing the way we cache stuff. So this approach is still immediate. It doesn't incur any latency from the displayed image. It's just, if we can avoid rendering so many surfaces, that would be cool. Oh, this is such a nice API. We even have the abort callback. What else can we do with this? Okay, I just removed all of the code which fills these surfaces. I'm pretty sure matrices are completely messed up now. Absolutely messed up. Yeah, it actually crashes. What is causing this crash? I don't see anything obvious. Okay. So we are assuming in some places that, for example, when we are drawing shadows, that we have a surface. Instead of omitting the surface size, I think there are better ways to do this. I think this is what we are interested in. Context display window. Here we should have the dimensions. Size. I guess if we had a crash here, then we'll probably have more of them in other places. So let's try to debug this once again. Interesting. And the only way to create a texture is to have access to some GPU context. When we create this picture recorder, we don't have that. the recording context is empty. Can I set this manually? We could store this direct context. Actually, let's go back to the mouse. We can actually, instead of having if-def, we can check this value. I expect more crashes because we are using this in many places. Okay, it seems it's not crashing actually. Nice. And this playback is just completely broken. Okay, maybe we can get rid of those bounds. Okay, we need to pass some bounds, I see.
Yoon's IMG says,
Hello again.
Hey, hello. I guess it's nice to let object know where it's located on screen. I think this sets up the clip so the objects know kind of specifically where they are. Okay, we have to do the same thing. To invert the matrix. I mean, this is the same as inverse of the current matrix. And this is kind of what we want. Oh, and this is the window. Okay, not bad. We have some stuff on screen. So after we reset matrix, we probably have to also move like here. And here is the result. It has poor FPS, poor but very stable FPS. Oh, when some things just glitch out of existence sometimes. Who knows? Oh, and those shadows. Okay, let's do save. Actually, I just want to save the matrix. We have some issues with shadows. And those lines. I think this clip may be messed up a little. Let's try to specify canvas bounds here. See. No, there are no issues with that. We also have shadows. The shadows do jump. That's still an issue. So we have three strategies now. So we can record this first to picture, then play it back. We can record it to surface and then blend the surface. And we can also record it like display it directly. Just for fun, I want to implement the other one. This is surrender to escape picture. And this is the just render. Here we are not doing anything like that. We are drawing to the actual context. This should be faster, I think. There we go. I mean, this approach also has issues with shadows. solely because when I am close and when I move an object, the shadows are in the proper position. When I drop an object, the shadow moves here. Very weird.
Guttural Helmet says,
Keep viewers on stream, boo. Can't remove the space Vithril kept Dutch too.
Nice. I want to test the old approach with surfaces. I guess surfaces didn't have this issue with shadows. Or maybe they did, who knows? Shadows are running away. Somehow. And let's switch to just drawing. I'm not sure if this is faster or not. It feels the same actually. Oh yeah, I wanted to fix those shadows. What's up with them? So allocation has this code here, pre-draw. Maybe I messed up the light position. Maybe that's it. Yeah, that's very likely it. I think we need pixel values here. Use this value. Much better now. Cool. Actually, when I look at this, so what FPS are we getting? Okay, maybe let's do the measurement. I will close this. Okay, this is not kind of fully finished. We still need to implement this part. So one thing which is surprising to me is that this rendering to picture, it seems similarly slow. Okay, let's get some numbers. So this is our picture-based approach. Should be terrible. I will actually print this in the event bench. I will run this a couple of times. I want to see if the results are consistent. I would say they are. Let's try the one without any sort of intermediate caching. Baseline. So this is the 0 attempts at caching anything. I don't know why it didn't print anything, it should have. Maybe the key was already pressed, because it seemed like it was closing kind of correctly. but way too early. Okay. Do I have other instance of automatic pressing Ctrl Q? Okay, so drift is all over the place. Jitter, those values are comparable. Okay, now I will try the render to surface. However, I will say I will fix this to true so that we always re-render an object. Let's see. Again, this could be very random. Drift seems to be higher here. Jitter not so much. It's hard to say from those values. When I do this properly and disable this Easy refresh, then we should have much better results. .36, which is the lowest so far. Drift 15 milliseconds, which is also the lowest. I mean, not the lowest. Close to the lowest. And this is meh. So actually drawing this stuff even once is already slow. I think the slow stuff is mostly the cables. You can actually measure this stuff from within AUTOMAT. So here when we do draw cached, I mean, I can only measure CPU time, but still. Sure, we'll put the measurement here. Let's get steady now. This will be lots of text. Okay, we don't see anything because we need to format it. here we can see that many of the objects, this one, it took 4 milliseconds. Or those connection widgets, incredibly slow. So somewhere here we have this draw cache, right? This is private. We don't want to use that. Exactly, so this is a moving average. So when we run this, it's going to just keep those values in cache, but we can also modify AUTOMAT so that on exit, for instance, maybe not here, but let's see, what do we do on exit? Let's maybe put them in a map. I don't know. So if it took more than 1 millisecond to draw a widget, now we can see the slowest elements. So window is very slow, but this is because window draws, everything. Root machine was slow probably because it was drawing just lots of objects. Macro recorder was 3 milliseconds, interesting. The worst offender are clearly connection widgets. It's something we have to just optimize manually. We're probably doing something silly, not caching stuff or caching stuff badly. Or compiling shaders on every frame, stuff like that. I can probably guess that the fast ones are the ones which are retracted, and the slow ones are probably the ones which have longer cable. Okay, I want to see how this compares to picture recording. Because I wonder if the slow part happens here or during playback. So let's get rid of that. Disable this. Yeah, and that's what I thought. So drawing the picture itself is very snappy. Playback, this is the slow operation. Right now we didn't have like even a single widget, which would take over a millisecond. Although it's almost suspicious. So actually going through the draw is fast. Probably the playback is what's slow. Let's measure this. Also fast. Maybe this, finish recording as picture. Maybe this is what's taking time. And if I put everything here, okay, I think I see. Yeah, also nothing. So we are seeing this because when we record to picture and we play it back, we are just moving the draw commands around. We are not actually drawing anything. The actual work happens elsewhere. So this is the only approach which actually forces the drawing to happen synchronously. Could also measure the baseline. We should also see everything being super fast. Oops. Yeah, no slow objects, and yet rendering was slow. This is because all of the slowness happens during flashing of drawing commands. So I guess this is kind of nice. So first of all, we have this entry.needs refresh. I think this is what's being set to true when we invalidated draw cache. Yep. So we have the expensive rendering, and we have, let's see, 2 threads. So we have main thread, we could also have renderer. Right now the rendering happens I mean, it doesn't matter if we use escape picture or not, because the main thread is not doing much work. It all happens when we flash. Okay, so I think this strategy with escape picture is going to work, actually. We just need to very carefully try to reuse the old surface. Okay, we are slowly getting there. It's getting late and my brain is fried after all this thinking, but I think we will figure this out. And I think we will try to render the picture synchronously. So we'll kind of have this this model. And the thing is, after we finish the picture, we still have a choice. Maybe it's better not to play back this picture and instead use older surface. And in parallel, it may be worth in the background. And this rendering, it's actually, because we recorded everything, it's in escape picture. We actually don't need any thread safety anymore. So I think if there is any surface, we should try to reuse it, just remap it to the current position. And only use what's cached. So essentially, our cache is going to be a little bit more complex. And the management of those surfaces is going to be a little more complicated. Yeah, I will keep thinking about this. And we will continue on Monday. So, see you then. Bye.